Jean-Marc, welcome.
Thank you.
I'm delighted to welcome you here today in the studio in London. You've travelled from Paris this morning.
Yes.
Travel all okay? No problems with Eurostar?
No problem through Eurostar.
Perfect. I chatted with your team before you came in and they told me 2 fun facts about you.
Yes.
First, you're turning into a bit of an expert in wine pairing. And second, you're an Iron Man. How cool is that?
Yes, that's cool. That's a little more than cool because it's challenging. But yes, I did finish an Ironman.
You've got the medal. That's all that counts. You did it.
I did it. I love open water swimming. That's where it started. And when I hurt my feet, I was advised to go to bike. And this is where I finished doing
it pulls you in, doesn't it?
Yeah.
You start somewhere. And then the wine pairing. Tell me a little bit more about that.
So I have a cellar and I love to cook and to invent recipes. And more importantly, what wine to pair with the recipe. But what I discovered, and actually in Italy, in Sardinia, was the fact that they had, for the first time I saw, a wine pairing or a non-alcoholic pairing. And I chose by curiosity the non-alcoholic pairing. And that has become a new passion because there starts to be quite interesting propositions that are not just substitute of wine, that are Grand Cru, like the wines, but made of different things. And that you can then pair with your recipes. And I did that for friends recently, and they were amazed. They used to have my Grand Cru, and now they have my Grand Cru of something else without alcohol. And it's fantastic.
That is so cool.
It was a real discovery for them and for me.
I could talk about wine, Ironman, and wine pairing for a long time, but I'm afraid we must move on. I'm going to start off this episode by asking you to tell our audience about network control.
So network control is a division of Hitachi Energy that does 2 main things. It manages markets, which is kind of a stock exchange for energy, with one constraint. At any point in time, the load, which means the demand, needs to be matched by the generation, because otherwise you're going to have problems with frequency and the things will go wrong. So it has a specific constraint on that. The fact that the lines need to be loaded correctly, no congestion. And then we have the control aspect of things, which means at transmission level, we call that EMS, but we'll come back to that. It's the transmission level, the big lines you see in the countryside and the substations that go with it. How to ensure that at country or region level, the electricity remains stable and that we optimize it to minimize losses. And then we have the equivalent at distribution. It's called ADMS.
What does ADMS stand for?
ADMS, Advanced Distribution Management System.
Got it, thank you.
And it's here, for you, it means what comes to the plug to power your meter at the front of your house. This is the distribution system. The goal here is not only to keep electricity safe, but in case there are problems, because it's a far bigger network, for example, a tree can fall on a line during a storm, it's how do you ensure you react as fast as possible. So the motto at transmission is keep the lights on. The motto at distribution level is react as fast as possible so that customers get their power back. And to support all that, we have something called a SCADA, which is basically, without going into acronyms, getting data from the field and being able to send orders to the field, open this line, close this line, this kind of stuff. And we have new type of things coming on the field called phasers that are far more fast than traditional ways that we're going to see. Why is it important? Why fast is important is going to be one of the next topic we address.
What is a phaser?
It's something that instead of measuring the network every 4 seconds, measures it 60 or 40, 50 times per second.
Okay, does it a lot quicker?
It's a lot quicker.
Right. You've mentioned a few products.
Yeah.
So can you tell me a little bit about the deployment of these with customers?
So customer deployment, when it's what we call new logo, greenfield, starts by the SCADA connecting the process to the field. And then you put on top the electrical knowledge, which means transmission or distribution management tools that will know what happens and be able to predict the N-1 I was referring to, or how to reconnect customers fast when they have problems. That needs the electrical knowledge. And a few examples of deployment. We are developing not only for states, but for subcontinents around the world, control systems that are global supervision. Example, New York ISO, where we are deploying in both the markets, so the stock exchange, and also the EMS, so the control side of things, for more than simply New York. It's a big market. Mm-hmm. Another example is ERCOT. ERCOT, where we are deploying mostly the stock exchange. They have just introduced their biggest market reform in the last 20 years that went live successfully just 1 month back. Another example is LS. LS is interesting because it's the Slovenian transmission system operator, mm-hmm. and they operate therefore the network for Slovenia. And they are using our latest platform to actually get what they have developed internally on top of our new platform in a gradual way so that innovation gets absorbed faster by us, but also by our customers. And so we are accelerating the value proposition to everyone thanks to this capability.
Right. One of the most dynamic areas of your portfolio is EMS, Energy Management System. What does the future of EMS look like for Hitachi Energy?
So the future of EMS looks like two main dimensions. First, transmission and distribution are going to be far more interrelated. Mm-hmm. And the breadth of the portfolio of how we leverage other sources of data that come from workforce management or the market system are all brought together so that we have more enlightened decision to manage the grid. That's the first thing. Orchestration across T&D, but also across the various elements of our depth of portfolio that bring the value. And that's what makes us different from several other players, is that we have this depth of portfolio that allows us to bring more value. The second thing is speed. As we get lower inertia, the merry-goes-round example, we need to react faster. So we are going to use artificial intelligence to help us predict what's going to happen. And when things really do happen, we're going to use automation to make that faster reaction. And in the end, the operator that used to do all the things by hand will have automated controls for more and more parts of the system and will become a supervisor of an automated world. This is the vision. This is where we're going.
So our software portfolio really does complement the hardware equipment that we're mostly known for.
Yes, absolutely. And don't forget that even in hardware, there's more and more software embedded in the grid automation portfolio as a whole. And all that comes together with those new type of devices and power electronics that are going to be devices used to have this fast reaction. So it's really the depth of the portfolio that allows us to innovate and bring all that together to lead the transformation on the market.
One of your colleagues in a different podcast referred to it as the brain of the operation.
It's actually exactly that. It's the brain of operation from the stock exchange to the real-time operation. And real-time is going to be even closer to real-time as we go.
Okay. And how is our system, how does it differentiate in the market from what our competitors are offering?
So at first, very reliable. It's field-proven at scale on some of the biggest systems on Earth. Why does scale matter? Because as you get more and more renewables, you'll have more and more things to look upon. So field-proven, and then having this look forward for new technologies, AI/ML enabled. I'll give an example.
AI/ML.
Artificial intelligence, machine learning.
Artificial intelligence, machine learning. Got it. Thank you.
Artificial intelligence is here to help unsolved problems that are hard to solve by the human. For example, computing inertia. We use the AI to help it. How to do a good forecasting of renewables. We use AI there to help us. So there are several examples where we already use AI today. It's not
built
just
into this EMS.
Yes.
Got it. Okay. So the next generation of EMS, the energy management system, is helping resolve all these challenges.
Yes.
That the market and our customers are throwing at us.
Yes. And the speed is going to be important, and giving the operator instructions what to do, and at some point in time, automate part of the process is where we're going.
So real-time closed-loop control is critical in today's grid. And is this a limitation of VMS, would you say?
Well, it's a limitation. Today it works fine. Mm-hmm. Tomorrow it will need to go faster because with a lower inertia, we'll come back to that, you will need to react faster. So speed and where you react is going to become two important factors of how we're going to control the grids tomorrow. And we are putting all that in motion as we speak.
In your digital world that we're discussing now, speed is of the utmost importance.
Yes.
Can you give us a little flavor? You've mentioned inertia a couple of times
So inertia, take the example of the
merry-go-round.
Mm-hmm. A traditional system used to have big rotating machines, which were the nuclear power plants, coal power plants, gas-fired power plants, hydro power plants, many of them and not many renewables. And so this was merry-goes-round with 20 kids on it. To stop a merry-goes-round with 20 kids on it, good luck. It has inertia. When you have a merry-goes-round with just one kid on it, it's far easier to stop. That tells you the difference between a big, heavy rotating machine and far lighter rotating machine. And that shows the difference in inertia. And what does it mean to the grid? It means that if something happens, you lose a line, you lose a transformer, you lose a power plant. Instead of having inertia that will slow down the reaction, you may have oscillations that are going to happen far more frequently. And therefore, you need to be closed loop control to prevent that from harming the grid. This is what lower inertia means because all those renewable resources are connected through inverters, so they don't bring as much inertia as what used to be those big traditional ways of generating electricity.
And that's why speed's so important.
Yes.
If inertia drops, we're in trouble.
The more inertia drops, and it will continue to drop, the more we need to forecast it, put it in the market so that you can put inertia products in this stock market. And also the more you need closed loop control to be faster and adaptive to cope with this reduced inertia.
Right. So you've mentioned a few types of control room technologies. How do they fit in with your wider software portfolio?
So in the wider software portfolio, we also have asset and workforce management, which means how do you manage your assets and how do you deploy crews on the field. You also have, I spoke of the market, the stock exchange.
Yeah.
You also have a solution for the market participants, the people who bid on the market. I'll take an example where AI is employed. It's called Nostradamus AI, stands for forecasting. This is used by market participants to hedge their bets when they put bids on the market, like a stock exchange.
Right.
But it's also used by the EMS to forecast what's going to happen on the entire network tomorrow. So, typical example of one technology being used across various parts of the portfolio.
Okay. And what is next for these technologies? What's next in your world?
Our world has been invented in silos. You had the market, you had the EMS, you had the DMS. They were invented separately with some common parts like SCADA, but that's a thing of the past. The two things that are going to change is having a data way to look at all those data together, and because AI will need, an operator will need all those data to be presented jointly, because you will need to know what happened next, what the market says, what the weather says, what happens on the field, all together. So it's transmission and distribution on markets all coming together. And the second thing is speed, automation, and artificial intelligence helping predict and give proactive measures for the operator. And at some point in time, the operators of the network will become supervisors of automation.
So two big things.
Yeah.
T&D orchestration and even faster speed.
Yes, absolutely.
Thank you so much. It's been very enlightening chatting with you today. Thank you for making time to come in.
Most welcome. It's a passion for me.